Okay, we'll start talking about section 5.2 about normal distributions and finding the probabilities for using normal distributions. So we know from what we said before that if a random variable x follows a normal distribution or is normally distributed, there's going to be ways to say the same thing. We're going to find the probability of that x will fall in a given interval, right? It's not going to be that the value of x is equal to, what I was going to say is falls within an interval. So the way to do that is finding the area under the normal curve for that given interval. So we did that in 5.1 for the standard normal curve. So now for any normal curve, how are we going to do it? Well, I explained this a little bit in the video from 5.1, is that we first convert the two values of my interval to z-scores. And then once you have the z-scores, then all you have to do is go back and forth with them, right? So what I mean by going back and forth is, let me put this on the side. Oops, sorry, that's not what I wanted. I want to move this on the side. This to the side. There you go. So if you have here's the standard normal curve, the one that has mean 0 and standard deviation 1. Okay, and over here I find a normal distribution that has mean 500 and standard deviation 100. So say I want to find the area to the left of 600 on this one. So this is the blue area that's right here. So if I didn't know other way to do it, what I can do is find the z-score. Because the standard deviation is 100, this 600 is exactly one standard deviation above the mean, which this tells me that the z-score is equal to 1. Right? I'm just doing the formula for the z-score, x value minus the mean divided by standard deviation, and you get a 1. Which means that under the standard normal curve, that corresponds to the value of z equals 1. So finding the area to the left of 1 under the standard normal curve is going to give you the same area that finding the area to the left of 600 under the curve that has mean 500 and standard deviation 100. Okay, so this is the same idea. Just for context and for future working, whenever we use z-scores, the letter z represents z-score. So we talk about values under the standard normal curve. And whenever we refer to a value like x, it means it's under a normal curve that's not the standard one. Okay, that has a different mean and a different standard deviation. Just an example. So they say that IQ scores follow a normal distribution with mean 102 and standard deviation 13. So what is the proportion of individuals with an IQ score of 95 or less? So I'm going to solve this two ways. First, just the approach that I just said is find the z-score. And so you find x minus the mean divided by standard deviation. The x value is going to be this 95 from here. The mean is the 102, and the standard deviation is 13. When you plug in those values, you get a negative 5.4. So this is the z-score. This means that it's about half a standard deviation to the left of the mean. So what I need to do is find the area to the left of negative 5.4 using the standard normal curve. Right, so you do, I have the class calculator here ready. Let's do that. So to find this, remember you go to stats. Be sure first that you're on the graphing calculator. If you're in the scientific calculator, it looks like this, and you press the stat, you don't have a big menu. So be sure that you are in the graphing calculator. Oh, I'm in the wrong. There you go. You have to click on the scientific. You're really doing the graphing calculator. Okay, now press the stat. The menu is a lot bigger. Distribution plots, and we're using the normal distribution. So down here in the corner, in the top, normal distribution, I'm doing with mean 0 and standard deviation 1, and I want the cumulative area to the left of a value. So the CDF is the cumulative. And if you want to see the picture here, remember you can click on this magnifying glass, and it gives you that picture. I want it to the left of, let's check. Wanted this to be to the left of negative 0.54. So you type here a negative 0.54 on the right side. You leave it blank here, and this is, I didn't type a negative infinity. If you leave it blank, it will fill with negative infinity. Okay, so in my notes, I wrote this like, just leave it blank here. I can probably have faded. You'll see here a negative infinity. Oh, that's too big. You'll see here a negative infinity, but faded, it will just show up there. So the area is 0.2945. This is the area. And the interpretation of this is, of course, that 29.46 individuals who take the IQ test will get 95% or less. Okay, so this is with the first approach. Now, this is the historic way of doing this. Like I explained before, we had access to tables, and to find the area under the standard normal curve, that only gives you areas to the left, and we only had table for the standard normal curve. But now we don't have to do that. If you realize, well, of course, when I type this number in the normal distribution in the class calc, in the calculator online, I have to type the standard deviation and the mean right here. Right? So I forced it to be the standard normal curve. But I can just do that and say, why don't I just do directly the one that has mean 102 and standard deviation 13? So I can type here this normal curve that has 102 and standard deviation 13. Of course, the graph is totally different, and this number doesn't make any sense. So the graph would be over here. Okay, now it's centered at 102 over here. But the value I have to plug in is not the z-score. I just plug in directly the 95, right? So just plug in here 95. So that's the same area as before. In fact, let me write it here so we have it both. So if I type, if you're in a computer, you can type normal dist. It completes to that command. I want the 0,1 and the CDF of negative 0.54. Yeah. So those two areas are the same. So when you were doing a problem from our textbook, maybe it will tell you to go and use to find the z-score and approach it that way, to follow the steps, which is fine. We still need to understand that interpretation. But in practice, if the problem just says find the area to the left, or what probability that this will happen, you can just directly find this. Okay, and what would you type in the quiz and exam? Well, I think you would type, like I have it here, just write normal dist 102, 13. I use the CDF, right? And you can leave blank here or put the negative infinity to 95, and that's the answer you got. So there's no need to get to the standard normal curve if you do it this way. Okay. So I'll stop this video here and make another short one.